show velocity of one molecule of any gas is same. This is first application of pressure due to ideal gas. We know pressure due to ideal gas, ideal perfect gas, that is B, 1 by 3 m by V c square. C is root mean square velocity. Not velocity. Show kinetic energy of one molecule of any gas is same. mc square 3 PV RT. Gas equation. RT half mc square multiply by half both sides 3 by 2 RT. This is pressure due to 1 mole of gas. So kinetic energy of 1 mole of gas 3 by 2 RT, or kinetic energy of N N means molecules. In 1 mole there are n molecules. Three by 2 RT. Either of 1 mole or n molecules where n is Avogadro's number. So kinetic energy of 1 molecule of gas 3 by 2 R by N into T, or 3 by 2 KT, K R by N. It is Boltzmann's constant. So this is constant, this is constant, this is constant. So hence proved. Whether the molecule is of oxygen or nitrogen or any gas, kinetic energy 1 molecule is same. Second application, kinetic interpretation of temperature. Kinetic interpretation. How kinetic related to temperature, how kinetic energy related to temperature, how velocity related to temperature. This is kinetic interpretation of temperature. A. Relation between kinetic energy and temperature. This is first part of kinetic interpretation of temperature, this relation, how kinetic energy is related to temperature. We know pressure due to ideal gas, that is P 1 by 3 m by b c square or mc square 3 pv or mc square 3 rt. pv is rt, or half mc square is 3 by 2 rt, or this half mc square is kinetic energy 3 by 2 t. This is constant, this is constant, this is constant, so kinetic energy this is the relation between kinetic energy and temperature, that is at 0 Kelvin or minus 273 degrees Celsius, kinetic energy of gas molecules is 0. We were doing kinetic interpretation of temperature, means relation between kinetic and temperature, means relation between kinetic energy and temperature. B, relation between RMS velocity and temperature. We know P 1 by 3 m by v c square, c square 3 pv by m t. C square 3 pv is rt, C square 3 pv by m and pv is rt. C square kt, this is constant, this is constant, this is constant, or C directly proportional to square root of absolute temperature, that is at 0 Kelvin or 270 minus 270 degrees Celsius, RMS velocity of gas molecules is 0. No question. Say directly proportional to this C naught T naught, C by C naught, T by T naught. T absolute temperature, C by C naught, T zero, T temperature in Celsius. So remember, for numericals, C by C naught, T by T naught or C by C naught is this, as well as C 3RT by M root. From here, see, at what temperature RMS velocity of gas molecules is double than at 0 degrees Celsius. At what temperature velocity of gas molecule is double than at 0 degrees Celsius? We know C by C naught, T plus 273, 0 plus 273. Initial was 0. RMS velocity says C naught. At this temperature, the velocity is C. Given is this. So it is 2 C naught by C naught. T plus 273 by 273. Squaring 4. T plus 273. 273. Cross multiply. So this is capital T, this all is capital T. So the temperature is this much Kelvin, but it is in Celsius, so T is 273. It is 9, it is 1, 8 degrees Celsius. What will be RMS speed helium at 40 degrees Celsius. If RMS speed of oxygen at 0 degrees Celsius is 460 meter per second, what will be RMS speed of helium? Helium at 40 degrees Celsius. Molecular weight. Helium, it is 4 gram per mole. C2 meter per second. T2 273 Kelvin. M2 32 gram per mole. We know this thing. We know this thing. We want to calculate C1. C1 by C2, 3R T1 by M1, M2, 3R T2, 3 with 3R with R, C1 by C2, T1, M2, a gram goes with gram, no need to change units. M2, T2, M1, it is 8. So C1, it is C2, 8, 313, 273. Solve it. It will be this. At what temperature? Of an atom of argon has equal to RMS speed of helium gas. Both are gases. Argon is gas. At what temperature of an atom of argon gas has equal RMS speed with helium gas? At minus 20 degrees Celsius. Given atomic weight argon 40 unit, atomic weight helium 4 units, 4 units. At what temperature argon rather we want to calculate this T1 temperature in Celsius, there it is in Kelvin. C1 C2 it is given T2 273 253 Kelvin. M1 40 M2 4 units, 4 units. Again C 3 RT by M. C1 by C2 3 R T1 by M1 M2 3R T2 root 1, both are equal. C1 is equal to C2 1 3R T1 M2 M1 T2 squaring both sides T1 M2 T2 M1. What we want to calculate T1 T2 M1 by M2 T2 is 253 M1 40 M2 4 T2 is Kelvin or T1 is T1 plus 273 T1 2530 minus 273 it is 7 5 2. It is 2 degrees Celsius. Boyle's law statement. Temperature remaining constant, volume of given mass of gas is inversely proportional to its pressure. That is V. When T is constant, or PV constant, or P1 V1 is P2 V2. This is statement. This is mathematical expression. Proof. P 1 by 3 m by v c square. C square was kT. P 1 by 3 m. kT or PV 1 by 3 m kT or PV constant, because this is constant, this is constant, this is constant, and temperature remains constant when T is constant. This is constant 1 by 3 m k, they are constant. If T is constant, then hence what? Proved. This is Boyle's law. Charles' law statement. Pressure remaining constant, volume of given mass of gas is directly proportional to its absolute temperature, or Vt, when P is constant, or V by T constant. This is Charles' law, or V1 T1 is V2 T2. Proof. We know pressure due to ideal gas C square. C square was kT. P 1 by 3 m by V kT. Take V to this side, V by T. V this side, T also this side. So it is 1 by 3 M K by P. This is constant, M is constant, K is constant. If P is constant, then these are already constant, 1 by 3 mk. So V by T is constant, hence 2. ये लूसक्स ला और रेगनाल्ड्स ला लूसक्स और रेगनाल्ड ला वॉल्यूम remaining constant, pressure of given mass of gas is directly proportional to its absolute temperature, that is P, when B is constant or P by T constant or P1 T1 P2 T2. Proof. P 1 by 3 M by V C square P 1 by 3 M by V KT C square is KT. P by T 1 by 3 m by v k. Now 1 by 3 m k, they are constant. These three 1 by 3 m k are constant. So 1 by 3 m k are constants. So if v is constant, then p by t is constant. Hence proved. Standard gas equation. PV is RT. For 1 mole of gas, derivation, we know pressure 1 by 3 m by v c square. Or PV mc square. C square is kT. Or PV 1 by 3 m kT PV. This is constant, this is constant, this is constant, so another constant. Hence proved. Or R PV by T, or P1 V1 T1, P2 V2 T2. For numerical purposes, the gas constant for 1 mole is PV by T. Also P1 V1 T1 is P2. The temperature is absolute temperature.